have a scenario here. We have Mrs. White and Mr. Brown.
Still comparing functions.
Mrs. White buys a used car for $3,000. She makes monthly payments of $300 until the car is paid for. Mr. Brown also buys a used car. His monthly payment plan is shown in this table. So we're going to compare these two functions. We want to find the rate of change and the initial value. How can we find the rate? Let's take a look at first the table. Let's take a look at Mr. Brown. How can we find the rate of change?
What's happening in the scenario? So now you're not just thinking about rate of change and initial value. You want to put them also in context. They both bought cars and they're paying off the cars. So think about what the rate of change would represent and what the initial value would represent as you're trying to look through and problem solve here. So let's go through it together.
So remember in me warm-up, we kind of looked for a pattern, right? When we were looking at the table, we looked for a pattern. So can we find a pattern here? We'll start. Yeah.
It's decreasing by $300.
It's decreasing by $300. So to get from $2,400 to $2,100, we're decreasing by $300.
How often? How often are we decreasing by 300? Every month. And how do we know every month?
Because in 0 month you had $2,400, and then once you got to the first month, you lost $300.
Right, so after that first month, that movement is not just a decrease of 300, it's also you advance 1 month. Those two, they work together, that's a relationship.
So for every 1 month, we're decreasing $300 because that's the amount that Mr. Brown owes. And every month, what is he doing? He's paying for every 1 month. He's going to pay $300.
So the debt he has is actually going to decrease over time because as he pays them money, he owes them less and less.
So for Mrs. White, what would her rate of change be? Here's the context. Mrs. White buys a used car for $3,000. She makes monthly payments of $300 until the car is paid for. What is her rate of change? Put it into the context. Go ahead.
Just 300. Remember, it's the rate of change. So it's 300 per month, but what, in terms of how much she owes, think about the movement. Like if you were going to graph this scenario, what does it look like? Because we want to be specific with our rate. It's going to be a negative, right? We're paying, our amount owed is going to go down 300 a month. Okay, so you were right with the 300, but think about representing that as the amount that she owes is decreasing.
Good. So now let's take a look at the initial value. For Mr. Brown, take a look at the table. What is the initial value? Put it into the context, 2,400. What does that mean? In this scenario, what does that mean, 2,400? 2,400 what?
For the monthly payment.
So it's the money that it's the money he owes. In this scenario though, take a look at the table. In the context of this scenario, take a look at this table. What else is it's not just the money he owes, what else is represented here? What's the zero mean? Okay, it's the X, which means what here?
So what did Mr. Brown do? Based on just that coordinate, X of 0 or month is 0, and amount that he owes is 2,400. What did he do?
He needs to owe $2,400 for when no time has passed, he has to owe $2,400.
Why? What did he do?
He just randomly woke up one day and owed $2,400.
You buy a car.
He bought a car. He bought a car. And no matter what, if you buy, you can buy a sweater, you can buy a car, you can buy a house. You buy something for an amount of money and you owe a certain amount. Okay, so the payment plan that was set up, what do you think his payment plan is? He's gonna pay back $300 a month. But in the beginning, how much did the car cost?
No, 2,000.
$2,400, perfect.
So we know that his initial value is $2,400 because he went and bought a car for $2,400. So that's how much he owed right from the start. When no time has passed, 0 months has passed. And now, what about Mrs. Wood? What's her initial value?
$3,000.
$3,000. So what did she do? What's the $3,000? She bought a used car for $3,000. So right now she owes $300,000. She walked onto the lot, no time has passed, she hasn't paid anything off yet, she owes $300 right from the beginning. I mean, $3,000, sorry, right from the beginning. Good. Okay, so let's create a table, because we want to compare. So when you're comparing, you kind of want everything to be in the same format. So we want to create a table for Mrs. White's plan, so we can compare it to the table that we used for Mr. Brown. How can we create Mrs. White's table? Her total bill is $3,000 a month. She's gonna pay $300. How can we make this table? Why for 0 are we putting 3,000?
But that's the value that she started off with before she started thinking of the car.
So yeah, so she walked in and 0 months has passed, no time has passed. She walked to buy a car, and she paid right away. She owes $3,000. So what about after the 1 month?
Well, since she's paying $300 each month, then $300 will be taken away from $3,000, which will be $2,700.
So 1 month has passed. Her monthly payment is $300. So now she owes $2,700. What about after 2 months? $2,400. How'd you get that? Why'd you subtract 300? Why'd you subtract 300? Every month she's paying $300. So what about the 3rd month? What about the 4th month? 6 months? 6 months?
There's nothing better than seeing his debts get smaller and smaller. I'm like getting excited for Mrs. White as we go through the table.
Alright, so we already talked about this, the rate of changes. So what are the rate, we already talked about what the rate of changes represent for each of them. What does it represent? For both of them, what does the rate of change represent in the context of this scenario?
Paying off her car.
Yeah, it's the monthly payment to pay off the car. Okay, so now we're gonna take Mrs. White and her payment plan and we're gonna graph it. How can we graph this?
Maybe you can go at a rate of 1,000, like for your X, like if you, then for your Y. Because you can't go like 1, 2, 3, 4. You
So what is the y-axis gonna represent here?
The amount of money she owes.
Yeah, that's gonna be the money she owes. What is the x-axis gonna represent? The months. So how do we wanna label this? How would we label the x-axis thing? Yeah, we could just go like 1, 2, 3, we could just go by 1 here. And what do we wanna do do we wanna go by ones for the y-axis? That would take the whole class by 1, 2, 3, 4, all the way up to 3,000. That would take the whole class, we'd be here all day. What can we do instead?
Make each 1 by 300.
Yeah, we could do that, 300. Alright,
Do we have other options?
is that the only thing we can do?
Go by 1,000.
You can go by 1,000.
Could you go by 500 if you wanted to? Yeah. Yeah, you have some flexibility with how you set it up.
Alright. So, we wanna go by 300? Okay, so let's start. What can we do first?
Um,
You got it.
Alright, what can we do first?
Thank you.
What?
Is that the top number?
Yeah, the top number 2,000.
We can plot coordinate them since we know that. Okay, so you know how the 3,000 is on the y-axis, and like we don't have they like off the bat didn't pay nothing, so he still owed 300. She still owed 300, so
3,000.
3,000.
Yeah, so Riley was saying that in 0 months, she owed $3,000. She hasn't paid anything off yet. So that's our coordinate is 0, 3,000. Can we just make a line with one coordinate?
No.
What else do we need?
We need a second.
Okay, so what point do we want to use? Can we use any of these points? What point do you want to use?
8,600.
8, 600. Alright, so coordinate 8, 600. There, we can make our line. Is our line increasing or decreasing?
Decreasing.
Why do you think it's decreasing?
Because you're paying $300 per month.
Yeah, because the amount we owe is lessening each month. We owe less and less each month because we're paying back monthly. So now, this is a graph that has both Mr. Brown and Mrs. White payment plans on there. These are their car loans. How are the graphs different than what we did yesterday?
So yesterday we did the trees, the diameter of the trees, like over time, we studied the scientists. How are those graphs different than the graphs of the trees?
Since we're paying each and every month 300, it's decreasing, and the one we did yesterday increased since the tree
Yeah.
was growing.
Yeah, this rate of change is going down. Well, our rate of change is represented as a negative because we're really looking at how much we owe over time. If we were graphing how much we were paying in total over time, that would go up. Because after 1 month I've paid 300, after 2 months I've technically paid back 600. That would go up. But this scenario, we're looking at the amount that we owe over time. Which if you think about as I pay something off, my overall debt goes down, which is why this representation is decreasing. We already did that. We already did that. We already did that. We already did those. We kind of did everything.
Okay, let's write an equation now. For Mrs. White's plan and Mr. Brown's plan, what do we need in order to write an equation for those functions?
Your constant rate or slope and your initial value or your y-intercept.
Okay, so we need the slope of the line, the y-intercept, those are also called, I like how you use both terms, the initial value is the same as the y-intercept, and then the rate of change is the same as the slope. For Mrs. White, what do you have? 3,000 minus 300x to be 3.
Yes.
Yes. How did we get that?
Well, since we have to since the whole entire debt is $3,000 and we're paying it off $300 per month, then it would be the total value of 3,000 minus how much money we're paying each month.
Good. Could I have written this like this? Are those the same thing?
No,
Why not?
because you even said it before that you're in a different perspective. Like you're saying how much you owe and not how much money you've given in total. So it wouldn't be addition.
So how are those two equations different?
Because you're adding on to his total compared
Okay.
to the next one.
But what if we show that see the one that we just did, what if, well, that's a positive 3,000, then we're taking away 300x, and then on top, it's
Oh,
a
no,
negative 300x plus 3,000, are they different?
I looked at it differently and
That's normal, that's common, right? See, the problem with this, and it's not a problem, but most of you, when you think about the scenario, okay, the debt is 3,000, we're paying 300 a month. Most of you actually want to write the equation y equals 3,000 minus 300x. You have this amount, you're taking away something per month. That's the natural instinct. When we graph, and I don't want to call it a shortcut, but our strategy when we graph that slope-intercept form, y equals mx plus b, is actually the top equation, where that m is your slope or your rate of change, that negative 300, and the b is your 3,000. Okay, so you are not forced to write an equation in slope-intercept form like it's at the top. You don't have to write your equation that way. What we want you to understand is the difference between what your rate of change is and what your initial value is, no matter how you write your equation. Some of you do the slope-intercept form. You just like it that way. So you know, like when I graph it, I start at 3,000, I'm going to go down 300, down 300, I'm going to do that. Others, when you think of the context, you do the 3,000 minus 300x. There is no wrong answer there. You can do either one, as long as when you translate it to a graph, you understand how to graph that.
So let's take a look at Mr. Brown. What's the equation for his scenario, his function?
So in that way you described it, we'll take negative 300x plus 2,000.
Plus, I just couldn't hear you. 2,400. Good. So where do we get the negative 300 and where do we get the 2,400?
The negative 200 2,400 is wrong.
Which one's wrong?
The 2,400 is 2,700.
Oh, it is.
Oh, is it? I'm sorry, I thought it was 400.
Oh,
Sorry.
sorry. Yeah.
I thought it was 4.
Can we go back and just look at the table? 2,400. All right.
You're being a good car salesman.
Trying to get us to pay more money.
All right, so where do we get, like, can someone put this into words for me? Y equals, into like the scenario. Y equals negative 300x plus 2,400. Let's make that the less mathy and more like, what does it mean here?
Translate that to the scenario. What happened with Mr. Brown?
For every week, for every month, sorry.
It's an expensive car if he pays that every week.
For every month, you're taking away $300 out of your debt.
Yeah, because he's paying it off. Exactly. And his initial debt was 2,400. This is very realistic, right? If you buy a car, you buy a house, most people do not walk in and pay cash. You're not going to go in and buy a $100,000 house with cash, right? You take out a mortgage. And what you do is you get a loan. And they give you all the money up front. They don't give it to you. They just pay for the house. And then you get a bill. Every month you owe the same amount of money. Well, typically the same amount. Right? So that's this scenario. They didn't go in with cash. They went in and said, can we develop a payment plan? And every month we'll pay back this amount of money so that after a certain amount of time, your debt is paid off. The only thing that this isn't taking into account is interest. Typically, a bank will lend you money knowing that over time you're giving them extra money. That's how they make money. Okay, but this scenario still shows that payment plan. Again, there's a lot of examples of payment plans. Houses, cars, cell phones now, right? A lot of the cell phone companies, you like pay for your phone over every month. It's like built into your bill, which is kind of fun. But still, these phones are expensive, so they build it in. So you don't have to pay the $700 up front for an iPhone. They could just pay, okay, like $40 a month, and then you'll just have it paid off. Makes it a little bit easier to pay for. That's what this scenario represents.
Does it take the same time to finish paying for the car with both plans? Same amount of time?
We'll have to make a difference.
I want you to talk to each other and groups on this. Do you think it takes the same amount of time? Do you think Mr. Brown and Mrs. White are going to be paying with the same amount of time to pay off the cars?
Think about who's going to pay their car off first.
But if you saw the first lady's hers, it took her 10 times. Well, I got one of them over like that. Alright. Alright, see.
Okay, so what do we think? Who paid their car off faster?
Mr. Brown.
Mr. Brown. How do we- Sorry.
It's Mr. Brown because he started off with $2,400 and each car is less, like, not each car is a different value. So since the lady hers would cost more, hers would take more time to be paid off.
What's the key here? So you know that Mr. Brown's car was cheaper to begin with, but what else matters in terms of who's paying it off faster? Right, because here's the thing. Let's say Mr. Brown, his car is cheaper, right? But what if Mrs. White paid back $1,000 a month? Who would pay their car off faster? Because why? It's not just, now the key is that his car was cheaper to begin with. But what happens with the amount that they're paying back? Go back to the graph and look at it. What do you notice about the graph? So his is cheaper. We see that because he has a smaller initial value. But what about their payments?
They pay the same amount of money going down. It's just that from like the starting points of Mrs. White and Mr. Brown, Mrs. White's starting point was 0.10, and then Mr. Brown's starting point was 0.8. So
Well, that's not where they're starting.
well,
They're starting at the debt.
yeah,
per
I meant
debt.
I meant the coordinates.
Right, that coordinate's 0.3000. I know what you're saying. So he's going to pay it off after how many months? 8, because what is that value?
That's the amount of money.
You pointed that out to me the other day. What coordinate is that?
The X.
It's the x-intercept. It's where your y value is 0, meaning your debt is gone. Okay? Their rates of change are the same. They're paying the same amount a month. The difference is she owes $600 more. So how many more months will it take her to pay off her car? 2 more months. She'll pay it off after the 10th month. You're right.
Okay, so now we're going to take a quiz.
Hold on, I have to shrink it a little bit so you can see the whole question. Explain them what they're going to do after.
Oh, weekly quiz. Below are two companies' rates for
Quiet
textbook-
down.
Below are two companies' rates for textbook rentals. What is the initial value and rate of change for each function? What is the cost to rent a textbook for 4 months from each company? So here's company A. There's an equation there, C equals $18 M plus 10. And it tells you C is the total cost and M is the number of months. And then company B tells you $19 per month per textbook and a $6 registration fee. So you're answering the two questions. What is the initial value and rate of change for each function? And what is the cost to rent a textbook for 4 months from each company? When you are done, this can go on your DOL sheet, by the way. When you're done, into the DOL bin, you have two options. Learning Target 7 is comparing functions. That's what we're doing, and we're comparing functions. Any Galactic Hero assignment that has Learning Target 7 in it is fair game. Or the workbook pages to compare functions are pages 75 to 80. This unit, a lot of the learning targets are woven in together. So you may see some of the Galactic Heroes are like Learning Target 7, Learning Target 4, Learning Target 3. Anything with 7 is where we're at. Or a workbook page is 75 to 80.
I have to do this first.